Viper chemistry students, let's take a look at how we solve radioactive decay problems. And so we'll take a look at number 7 and number 8 today on our radioactive decay worksheet. So number 7 reads, if there are 16 grams of a radioactive substance, how much will remain after 3 half-lives? Okay, so let's take a look at then how we would solve that. So 16 grams is what we start with. Okay. And that's our starting amount. And so how you would set this up is you basically just say at 0, which is now, we have 16 grams. Okay, and after 1 half-life, there would be half of the 16, which would be 8 grams. Notice that on this side of the column, I have amount, and G is representing grams. And then after 2 half-lives, the 8 then is cut in half, so now we're down to 4. And then after 3 half-lives, we're cutting the 4 in half down to 2. So this then is the solution to that problem. So after 3 half-lives, we would now have 2 grams. Okay, so that was number 7. Let's move on to one that reads a little different, and this is number 8. We'll erase these values, and really about the only way to do these problems is to set up a chart like this, or a set of columns like that. I'm going to go ahead and add in a time value on this one, and that'll be in seconds. So I want to put that down here to be consistent. Okay, so we'll add time in because the problem reads, how long does it take for a 100 gram sample of astatine 81, which is an isotope of an element, to decay to 6.25 grams if the half-life is 33 seconds? Okay, so let's see how we would set this up. We have 33 seconds and we have 100 grams. So we have 0, we have 100 grams, and then we have 33, or we would have a time at 0. So you always want to start with your time at 0. Okay, after 33 seconds though, so after 1 half-life, 33 seconds would have gone by. And now we're at 50. We just continue. The next second half-life there is 66 seconds because we're going another 33 seconds of half-life. But now our 50 is reduced to 25. And in the third half-life, we have now 99 seconds of time. And now 25 is reduced to 12.5. That's half of 25. And then in the fourth half-life, we're at 132 seconds, because we're adding 33 seconds every time. And then the 12.5 divided by 2 is 6.25. So that's how you know then, as the problem reads, it's like how many half-lives? How long does it take? And so we could look at that like, well, it took 4 half-lives. And then we can determine the total amount of time from adding 33 seconds each time. Okay, so I hope this helps you. But again, reach out, send an email if you're having troubles with these problems. There will be a key available eventually. Usually I've been posting those keys on Fridays. So try to work hard at developing that skill of half-life problem solving, and we call it radioactive decay. But again, reach out to me if you're having problems. All right. Thank you for watching.